today we're going to look at factoring, 3 different factoring methods. You should have a notes handout. There are 3 different methods we're going to look at. The first one being greatest common factor. Sometimes we call that GCF. We're also going to look at difference of squares. And we're going to look at grouping. When we talk about factoring, really we're wanting to write a polynomial as a product. So we might have some kind of polynomial that looks like this. 10x squared minus 20x minus 80. We're going to factor that, put it into, or write it as a product. Product means what? Multiplication. And there's lots of different factoring methods that we're going to try to learn. The first one being greatest common factor. I know you guys have done greatest common factor for many years. Maybe not called it factoring, but you've done greatest common factor for many years. So some things that I want you to think about. What does every term have in common? Or think of this as a distributive property in reverse. So in example number 1, I have x to the 4th, I have plus xy. When I say x to the 4th, that's really x times x times x times x. 4 x's, right? And xy, that means x times y. Well, what do those 2 expressions have in common? An x. Okay, we have an x in common. So I would say my greatest common factor is x. In parentheses, we're going to write what we have left. When I take away that x that they have in common, when I factor it out, what do I have left? Well, I have 3 x's, so we'd say that's x to the 3rd power, plus, I'm just bringing down my sign, here I just have y. I wrote it as a product. This is the factored answer. There's no solving yet. We eventually will solve, but we're just factoring, writing it as a product. Look at number 2. 3a cubed minus 15a squared. So that's 3 times a times a times a minus 15. Well, 15 can be broken down into its smallest factors, 5 times 3, and a squared is a times a. So what do we have in common? We have 3, and we have how many a's in common? 2 of them. So let's write what we have left. We have in common 3, and we have 2a's, so we'll say that's a squared. In parentheses, we're going to put what we have left. When we take it out or factor it out, that's 3a squared. Well, I have 1a, and minus, just writing down my sign, 5. When we do the greatest common factor method, it's reverse of distributive property. Usually we have a problem that looks like this and we're asked to simplify by distributing, aren't we? It's just reverse. Same thing here. I could distribute that 3a squared. If I distribute 3a squared, it should give me the original problem that I started with. How about number 8? What do we have in common here? Well, if you can break 8 down, 2 times 2 times 2. 4 times 2 won't work. Because can't 4 be broken down into 2 times 2? Okay. So we need to break it down as small as we can. X squared is x times y. 4xy squared, that can be broken down into 2 times x times y. So what do we have in common? How many 2's?
2.
So that's really what? 2 times 2 is 4. We have 1x in common, and it looks like we have 1y in common. So let's write what we have left. We said we have 2 times 2, which is 4. We have an x and we have a y. So in parentheses, put what you have left when you factored out a 4xy. Looks like we're left with 2x. Bring down your sign. Minus y. Number 4, we have 3 terms. Does that matter that there's 3 terms? No, we just have 3 different things to look at here. So 2b cubed minus 6b squared plus 10b. Well, 2b cubed, that's 2 times b times b times b. Negative 6 can be broken down to negative 2 times 3 times b times b. Plus 10 can be broken into 5 times 2 times b. So what do we have in common? We have to have it in common in all 3 terms this time. So I have a 2 in each term. 2, 2, and 2. It looks like I have how many b's in each? 1. So my greatest common factor is 2b. So I'm left with b squared, b times b, or b squared, minus 3b plus 5. I want you to try number 5, please. All right, let's move on to difference of squares. I think you'll like difference of squares. It's a little bit easier, I think, than any others. It goes pretty quick. Okay, for difference of squares, it is going to require 2 perfect squares to be subtracted in order to perform this method. You have to have 2 perfect squares and you have to be subtracting. Now, we are going to still look for the greatest common factor first before doing difference of squares. And we need to make sure that our final answer cannot be factored any further. This is really FOIL in reverse. Here is a problem that I might have. I want to go ahead and FOIL this out. Do you remember how to FOIL?
First, outer, and last.
We'll multiply the first terms. A times a is a squared. A times negative b, negative ab. B times a, positive ab. And last, b times negative b is positive b squared. If I simplify that, I have a squared plus b squared. These middle terms.
Would it be a negative b squared for this b times a negative b?
Oh, it should have been. Yeah, it should have been. I just wrote the wrong sign there. You are correct. So this would be my answer if I FOILed. When we do difference of squares, we're actually going to work backwards. I'm going to be given this answer, and I want to factor it to look like that answer there. Okay, we're working backwards from FOILing. So notice our parentheses. If you take the square root of a squared, what do you get? A. And the square root of b squared is b. One sign is a plus, one is a minus. And that will be always. It'll always happen. So look at example number 7. Do I have what I need? Do I have 2 perfect squares that are subtracting? Yes, I have 2 perfect squares that are subtraction. I have x squared and I have 16. 16 is a perfect square. Look at the clock. Is it 16 on the clock? No. Square root of 16 is 4. Okay, and we are subtracting. So let's go ahead and set up our difference of squares. I'm going to have 2 parentheses. Side by side, we're writing it as a product. So what is the square root of x squared? And what is the square root of 16?
4.
1 is plus and 1 is minus. You could have flip-flopped those as well. How about number 8? That's my final answer. Number 8. Do I have 2 perfect squares that can be subtracted?
Yes.
Yes, I do. 81 and x squared are perfect squares, and so is 4. So we'll do difference of squares. What is the square root of 81x squared? 9x. What is the square root of 4? 1 is plus, 1 is minus. Number 9. This one looks a little bit different. I've got x to the 6th and y to the 6th, which actually those are perfect squares. 16 is a perfect square, and so is 36. I had my subtraction. However, there is a greatest common factor. 4. 4 goes into 16 and 36. Let's factor out a 4 before we do anything else. We said we had to do a greatest common factor first. Remember, when we factor something out, that's like dividing by 4. So I want to divide both terms by 4. 16x to the 6th divided by 4 is 4x to the 6th. 36y to the 6th divided by 4 is like 9y to the 6th. Now I believe in parentheses we have two terms that are perfect squares, both of which are perfect squares. 4 is, 9 is, x to the 6th is, and y to the 6th is. We have subtraction. So let's go ahead and factor using difference of squares. So let's talk about this x to the 6th. When I take the square root of x to the 6th, really what I want to know is what two terms can I multiply that's going to give me x to the 6th? X to what power? X cubed. When you multiply your variables, we add the exponents. So the square root of x to the 6th is really x to the 3rd. It's going to be 2x to the 3rd. What is the square root of 9y to the 6th power? 3y. 3y cubed. 1 is plus, 1 is minus. If you factor out a factor, greatest common factor at the beginning, I do need you to bring it down and make sure it's part of your final answer. Problem number 10, we also have a greatest common factor. What number goes into 200 and 500? 100. So 100 is our greatest common factor. I need to do that first. Remember, greatest common factor is like dividing, in our case, by 100. Is there anything else that I can take out of both terms? A b. 200 divided by 100 is 2a squared, and b divided by b is going to cancel. Negative 500 divided by 100. Would I put a b? Yeah, oh, on the outside. Yes, you're correct. 500 divided by 100 is? Minus 5. The b's are going to cancel. B divided by b is going to cancel. Can I factor this further? Is this a difference of squares? It's not. Why not?
Because they're not perfect squares.
5 isn't in, neither is 2. Very good. So that is actually as far as we can go. 100b times the quantity of 2a squared minus 5. They have to be perfect squares for you to continue to factor. Number 11 is x to the 4th minus 625. Do we have a greatest common factor? No. So let's go ahead and factor. We do have two terms. They're difference of squares. So what is the square root of x to the 4th? X squared. X squared times x squared gives me x to the 4th. What is the square root of 625? I think I can go further. What can I do, Logan? I can do difference of squares again. Look at that second parenthesis. I can do difference of squares with it. Why can't I do difference of squares with the first parenthesis? Right, it's not subtraction. So I'm just going to bring down the first parenthesis. I can't do anything else with it. But the second parenthesis, I have two terms, two perfect square terms that I'm subtracting. So what is the square root of x squared? And the square root of 25? So this time I have 3 parentheses. One more year, number 12. Do I have a difference of squares? Why not? Right, well, it's not subtraction, it's addition. This is not factorable. If something is not factorable, remember what we say? Nope, no solution, we're not solving. What's with the P?
Prime.
Prime. If something is not factorable, it is prime. We actually have a third method on the back side. I know there are a couple problems on the back. Real quick, let's look at number 13. I'll probably be our last one. I don't know if we're going to find 14 today. So what number goes into 898?
Not eight. That's a lesson.
They're both even, so 2 definitely does. Let's try with 2 first. Do we have any variables in common that we can take out? Nope. So in parentheses, let's put what we have left and we divide by 2. 400 x squared y squared minus 49 a to the 4th. Do I have a difference of squares? Is 400 a perfect square? Can I take the square root of 400? Yeah. 49 is a perfect square. So let's do difference of squares. What is the square root of 400 x squared y squared? 20xy. What is the square root of 49a to the 4th? 1 is plus, 1 is minus. So greatest common factor, just to review here real quick. Greatest common factor, we want to know what does every term have in common. It's the distributive property in reverse. We're working backwards. To do difference of squares, we have to have 2 perfect squares that are being subtracted. Remember to look for that greatest common factor first. You have to factor that out first, otherwise it won't be in simple or in factored form. Okay, I do have some problems for you to try, but I'm going to have to cut some of them off because we didn't get through grouping.